If you watched the previous video, then you should be wondering to yourself, what exactly is a limit? Well, in this video, I'm going to be showing you what a limit is, and then we can extend it and talk about what a derivative is. So in limits, the fundamental idea is about getting closer to a certain point. So let's say we've got some point over here, x, and we've got some other point over here, a. And a can move. So a is going to get closer and closer to x. Now it's not actually going to reach x, but it's going to get closer and closer to x so that it effectively becomes x. It's not x, but it kind of becomes x. We get arbitrarily close so that we can observe the behavior of a as it gets closer to this point x. We write this as the limit lim as a tends to x, and we say, well, what do we want to observe exactly? Well, we want to observe what happens to f of a as it gets close to f of x. So it's the limit as a tends to x of f of a. And that's all we mean by a limit. Now the derivative of a function is going to be slightly longer to talk about, but we are going to define it and we're going to do it carefully. So when we have some function on a set of axes like this, we want to talk about gradients. Well, this function here, I'll call it f of x, doesn't have a numerical value for the gradient, if you like, because if you notice, it's constantly changing. We've got this changing slope here, but we want to kind of zoom in on any point. So we're going to zoom in on this point in particular because we can actually see it. And we want to talk about the kind of gradient. So like that, let's say that's roughly the gradient of the line. So over here, we are going to zoom in such that it effectively looks like a straight line. If you zoom in close enough, you can kind of imagine that it will start to look a bit more like a straight line. And we want to say, well, the difference in 2 points, the difference in their y values and their difference in their x values. We've got the difference in y, which we're going to call little d y, and the difference in their x, which we're going to call little d x, and the gradient of this straight line, if you will, is dy divided by dx. You may have seen this notation before, and if you have, then the next bit is going to be quite straightforward for you. To make the next bit a lot more simple, we're going to label this little point here, we're going to label that x, and this is just the x coordinate of that point, by the way. You know, the y coordinate will be f of x, but we don't need to write that in just now. And the next point over here, we're going to call that x plus some value h, because it's h more than x. So you might argue that x plus dx is x plus h, and so on. So we've kind of relabeled this dx as h. They are the same thing, but I'm just calling it h for simple reasons. So what we're going to do is we're going to say that we want h to become as small as possible, and what that does is it makes these 2 points as close together as possible. So we're going to say that the change in y is, well, you might be able to see that it's f of x plus h minus f of x. That is the change in y values. So this y value here is f of x plus h, and this y value here is f of x. And we're going to divide that by the change in x. And all that is x plus h minus x. You can cancel out those x's, so we just get h on the bottom. Great, okay. So the gradient of this straight portion of the slope, this zoomed in version, is just going to be f of x plus h minus f of x, see that, divided by h. Great. Now what we want to do is we want to do that part I said earlier about making them arbitrarily close to each other. So what we do is we use the limit from over here. We say that the limit, as okay, what do we want to tend to what? We want h to get closer to 0. That means that these 2 points will be effectively the same. So the limit as h tends to 0 of this thing. So f of x plus h minus f of x divided by h. And that is the gradient of the line. And notice that because we've picked arbitrary points here, x and x plus h, these can be anywhere on the function. This is the gradient of the function at any point we choose. All we have to do is evaluate this, and you can even do one step further and evaluate it for the entire function, and then we get a function which we denote as f dash of x, which is the value of the gradient at every point on the graph, on the function. And that's what we call the derivative. This is called the derivative of f.